Hello, my name is Carsten Timmermann and I am a historian of science, technology and medicine at the University of Manchester in the UK. I want to share with you today and talk about a short documentary film commissioned for the American branch of the Swiss pharmaceutical company Hoffmann La-Roche in 1979. I'm grateful to the Roche Historical Archives for the permission to include clips from the film. I will talk about the message of the film rather than discuss its production. But it is worth mentioning that the film was made by some of the most highly regarded documentary filmmakers in the US at the time. Francis Thompson, Alexander Hammid and Theo Kamecke had been awarded an Oscar for an experimental documentary they produced for the 1964 World Fair entitled To Be Alive. And they had produced a feature-length documentary for NASA in 1971. The title of this was Moonwalk 1. If you watch this video in YouTube, you can find links to these films in the panel below. But now, without further ado, let's watch the opening sequence of The Quest.
Throughout history, man has lived in terror of disease, the pestilence of biblical times, plagues that ravaged ancient India and China. In the 14th century, plague destroyed perhaps a fourth of the world's population, nearly 25 million in Europe alone. In 1740, the little town of Haverhill, Massachusetts lost half its children to diphtheria. The influenza epidemic of 1918 killed 10 times as many as the First World War. Cholera, smallpox, yellow fever, typhoid, tuberculosis, polio. Names that once struck fear into whole populations are now but words in books. These diseases have been conquered by modern medicine. Lung cancer, coronary thrombosis, leukemia, bronchitis, emphysema, hypertension. Over half the people in this city will be afflicted by diseases of the heart alone. 1 out of 4 of the people living here will be stricken with cancer. Arthritis will cripple 8%. 5% will suffer diabetes. Statistics. Until it comes down to one individual. One single human life, a relative, a neighbor, a friend, suffering from a disease for which there is still no cure. How long will it be? How many lifetimes before the diseases we fear have followed the plagues of the past into history? Man's fight against disease goes on throughout the world, in hospitals, in universities, and in a place like this, the research laboratories of a modern pharmaceutical company. These buildings comprise one of the world's most important centers for the development and manufacture of therapeutic drugs. Part research, part factory to support that research. Some of the cures for the diseases that still afflict mankind today may come from this very place. But the diseases of today are far more complex than those of the past.
Okay, so in the sequence that is a bit reminiscent of Powers of 10, we have homed in now, literally from outer space, via downtown Manhattan, via suburbia and a lonely farmhouse, to the headquarters of the US subsidiary of Swiss pharmaceutical company Hoffmann La-Roche in Nutley, New Jersey, about 30 miles from downtown Manhattan. Meanwhile, the narrator has taken us on a whirlwind tour of the history of medicine and also homed in on the diseases of the risk factor age, namely heart disease and cancer, non-communicable diseases, as the late 1970s were a time when epidemics were considered a thing of the past, and infectious diseases were believed conquered, something that may be hard to believe today in 2020 during a major worldwide pandemic. I encountered this film in the Roche archives in Basel when I was doing research for a book on the history of Roche's cancer drug portfolio. And it was one of the few glimpses I got into the company's research labs in the 1970s, the period I was interested in. I want to argue that the quest illustrates a particular phase in Roche's approach to scientific research, a wholehearted embrace of fundamental rather than applied research, funded by income from a number of blockbuster drugs. It is also a piece of scientific marketing. The company wants us to see that it is investing in fundamental research. The late 1970s and early 1980s marked a turning point for Roche and for the company's cancer research portfolio. Roche had developed a couple of cancer chemotherapy drugs in the 1950s and 60s, which were reasonably successful. However, financially, cancer drugs were insignificant. In fact, no pharmaceutical company made much money with cancer drugs. In the mid-1960s, sales of cancer drugs only accounted for 0.1% of the world market in pharmaceuticals. By the early 1970s, the share of cancer drugs had increased slightly to 0.3%, or just over $37 million US. Roche were making most of their money with other drugs. What turned them into the world's leading pharmaceutical company were sales of the likes of Valium, Librium, and other tranquilizers, mother's little helpers. But already in the late 1960s, it was clear that this bonanza would not go on forever, and Roche management looked for new directions. They decided to invest a considerable chunk of money into basic research, and particularly in molecular biology. Here you can see Vice President for Research John Burns and others in 1971 marvel over a model representing the translation of genetic information into proteins and into potentially lucrative products. The company funded a purpose-built Roche Institute of Molecular Biology in Nutley. In Basel, they funded an institute for immunology. These were institutes for basic research, entirely funded by the company. Today, cancer drugs form the major source of income for Roche. With their subsidiary Genentech, they developed a new type of blockbuster, compounds such as Herceptin and Avastin. What is the difference between these and the older chemotherapy drugs? Herceptin and Avastin are celebrated as targeted therapies. But to be fair, most new drugs since Paul Ehrlich's days have been celebrated as magic bullets. What makes Herceptin and other new cancer therapies different is that they are biological molecules produced using biotechnology. My argument in the book is that one compound in particular that Roche were developing in Nutley in the late 1970s marked a key turning point in this development, and the quest celebrates this. Interferon promised to be a natural cancer cure, different from the nasty chemicals that have been used in chemotherapy so far. But let's return to the quest and listen to Sidney Pestka, one of the researchers at the Roche Institute of Molecular Biology, who will tell us more.
Infinite complexity, infinite possibilities. The cure may be in a molecule that exists only in the imagination, or it may be found in the chemistry of the body itself, hidden from our understanding because of the subtle nature of its activity and the complexity of its structure. Such a molecule is interferon.
I wish I could tell you what the molecule of interferon looks like, but so far we know nothing about its structure. We know a little bit about interferon. We know its size and we know its composition. Interferon is made in very minute amounts by the body cells. It is part of the protective system of the body. It has been known from studies carried out in many laboratories throughout the world that interferon has effects in curing virus diseases and can treat certain cancers. And we have been carrying out certain studies with interferon in this laboratory. We have, in the last few months, we've been able to purify interferon so that we have the pure material on hand. And with this pure material, we'll be able to answer the questions as to whether the pure material has the same effects as the crude material in treating virus diseases and human cancers.
In research labs throughout the world, the search goes on. It is an endless effort, a costly effort. Even when the cure is found, there are many problems still to solve.
There are many problems still to solve, indeed. Interferon was one of the key target molecules in the biotech boom of the 1980s, and Roche were not the only ones trying to clone it and turn it into a drug. It turned out that Roche needed a partner to have a chance to win that race, and they joined forces with Genentech, one of the leading new biotech startups in the San Francisco Bay Area. This was not an uncomplicated relationship, but it was successful in that Roche and Genentech were the first to make a biotechnologically produced interferon clinically available in 1986. Interferon was not the miracle drug it was hoped to be, but it marked the beginning of a Genentech-Roche collaboration which provided the foundation for cancer medicines like Herceptin and Avastin. In 1990, Roche owned 60% of Genentech's shares. So, had interferon proven that the investment in fundamental research was worth it? It certainly helped justify the increasingly high prices charged for the new compounds. Let's return to the quest for one last time.
That final product, after years of development, that drug that ends up in the hospital or on the pharmacist's shelf, is what's going to pay for the research that goes on here. To support a major research effort requires a large expenditure in money, personnel, and space. And therefore, one has to make a decision. What type of research project should be supported? Of course, there's a tendency to lean towards short-term projects in which there's a reasonable chance of success and the development of a new drug. But a commitment must be made to long-term exploratory research. This research may not be related to drug development at this time, but from it will come new insights, unique technologies that we will need in the future. Someone always asks, why has it taken so long to find a cure against cancer? Well, the truth of the matter is we just don't know enough. We need new concepts and new technologies to find out exactly what is going on within the cell.
I hope I have convinced you that the quest illustrates a particular phase in the history of this company's attitude towards science, a particular pharma vision, marked by large-scale direct investment in fundamental research, pursued in labs entirely funded by the company. This phase ended in the mid-1990s, when Roche wound down its Nutley operations, including the Roche Institute of Molecular Biology. But we should really let the Roche scientists in 1979 have the last word.
But I think most scientists would agree that the real benefits that will come from genetic experimentation are long-term benefits, things which we can't even envision right now. And these will come out of the increased understanding of the way DNA is structured, the way genes function in normal development, and the way they fail in disease.
The great successes of medicine in the past have all to do with diseases resulting from the impact of the environment, resulting from the intrusion of bacteria, from malnutrition, or simply from physical injury. In contrast, the diseases which we study in our laboratories have an entirely different origin. They result from within our body. They result from the decay of our body, in short, from aging. All men die, but some die of old age. How can we delay the onset of the crippling diseases of aging? That's the question. It is our intention to develop drugs and make drugs available which enable us to live out our natural life, free, happily free from the terror and cruelty of disease.